kinetics, or it also called as dynamics. In earlier kinematics, we discussed about the motion of a body along a straight line or in a two-dimensional motion, means one-dimensional motion and a two-dimensional motion. We didn't discuss about the why the body is in motion, what is the cause of that motion. But in this unit, the fifth unit of in our first year, that is the laws of motion. Laws of motion basically discuss it's a dynamics, it's a branch of science, we know that which is a branch of mechanics, and also we discuss about the force and its motion of a body and cause. Cause means the force. Due to the force applying on your body, the body would changes or it tends to change its position or its state. So in this case, dynamics, we discuss about the cause, means in kinematics, that is also called as statics. When the body is in motion, we didn't discuss about the cause why that body is in motion. In this unit, we are going to discuss about that the cause of the motion, that is force. Cause of the motion of that is force, which is given an idea about the motion of a body due to the force is called the Newton's laws of motion. He give the first information about that. Newton, Sir Isaac Newton is give the theories about laws about motion. Those are laws of motion. There is a three type of laws of motion as there. Newton's first law of motion, and second law of motion, and third law of motion. In this case of the first law of motion, we discuss about the force and inertia. Force and inertia. That means to say, whenever the body is under the influence of some of the force is acting on that, then that will be changes its state, or it rests, or either it is in motion, then it will changes its state of rest, or if it is in a uniform motion. So in that case of the body which is unable to change its state by itself, when the net external force is 0, when the net external force is 0, if the body will unable to change by itself the state of rest of uniform motion or of uniform motion, that is called as inertia. So let us discuss about the Newton's laws of motion. In that case of the first Newton's law of motion, that is Newton's first law of motion is, if every body continues its state of rest or of uniform motion in a straight line, unless it is acted by an external force, a net external force. Means for example, if the body is staying at rest, then if we want to change its position, we should apply some force on the body, then only the body will change its state from the rest to the motion. Either if we want to ride a bicycle, when we use the force on the pedal, then only that bicycle wheel goes on increasing, its velocity will be changes, means that position will be changes from the rest to the motion. When the body is in uniform motion, unless there is no any external force acting on that body, it continues its state of motion, its uniform motion. The body stays in uniform motion unless if the body is not acting by any force. So that here, according to the Newton's first law of motion, every body continues its state of rest or of uniform motion along a straight line. Uniform motion along a straight line unless it is acted upon by a net external force. It is acted upon by a net external force. That is the statement of the Newton's first law. Means whenever the body continues its state of rest or it continues its state of motion, that will continues along a straight line. Whenever it is motion, it continues its straight along a motion unless you applying the net external force on the body. If the body applied, some of the force is applied on the body, then it changes its state. Either it is rest or it is in uniform motion. Whenever we are riding the bicycle, whenever we accelerate the bike, then the engine will increase its velocity. Means whenever the body is in uniform motion, it changes its velocity, or maybe the, if in case of by using the force of the, if we changes the direction of the body, means that velocity uniform motion changes by applying the force. In this Newton's first law we will discuss about that force and inertia. It is explained about that force and inertia. In Newton's first law of motion it explains about the force and inertia. Force and inertia. And whenever the net external force on the body is 0, the net external force on an object is 0, the acceleration of by object, the acceleration of object is 0. We know that if unless we applying some of the force, or unless we applying the force on the cycle, whenever we are riding a cycle, then unless we are applying the force on the pedal, the velocity will not change. If the velocity is not changed, that body is in uniform motion. The body will be in uniform motion. If you think that some of, unless we are applying any force, the body will not stop. But after traveling some distance, bicycle will stop due to some of the frictional force between the road and its tires, because some of the force is acting on that body. So that's why the bicycle will be stopped for traveling some of the distance. So that here if the net external force is on 0, then acceleration is also 0. The acceleration of an object is also 0. This is about Newton's first law statement. Once again, every body continues its state of rest or of uniform motion along a straight line unless it is acted upon by a net external force. There is a statement of Newton's first law is nothing but unless applying the force, the body will stays in the same state, continues its same state unless applying the net external force. Okay, so in that case of in the Newton's first law, we discuss about the force and inertia. In that case, first one is the force. Force means a physical quantity which changes or tends to change the state of a body, either a state of a rest or of uniform motion, is called as a force. A physical quantity which changes or tends to change the state of rest or of uniform motion of a body is called a force. For example, if this piece of chalk is there, I am not applying any force on that body, the body will stay at rest. Whenever we apply some of the force, then that body will change its state. Means some of the force is applied on the body, so that's why that body will change its state. Either the some of the different types of force is acting on that body, like a gravitational force is acting on body, so that's why that body will comes to the ground whenever it is releases from certain height. So that here it is defined as that which changes or tends to change the state of a body, either state of a rest or of a uniform motion along a straight line. That means a physical quantity that changes or tries to change the state of rest or of uniform motion along a straight line is called a force. The force measures in CGS units, that is in dynes, and in SI system newtons. So Newton means when the force is measured in newtons in SI system, and in CGS case the dyne means what Newton is equal to, Newton is denoted with a capital N. Either if you want to write the full name, we should write in small letters because of it's the name of the scientist. He gave an explanation about the force and inertia, means about the Newton's laws of motion. Newton gave an idea about Newton gave this laws. So that's why here Newton we should write in small letters whenever we are writing the total name. In case of we are giving the unit, and if in case of by the single letter we should give it be the capital letter. So that 1 Newton is equal to 10 to the power of dynes, which is equal to, means here the 1 dyne is also, we can write that 1 dyne is equal to 10 to the power of minus 5 Newton. 10 to the power of minus 5 Newton. So this is the measure of we can measure the force by newtons and dynes in CGS system dynes, and in SI unit will be there Newton. So the types of the forces, how many types of the forces which is acting on that bodies, are either particles or molecules or everything. So here the gravitational force, we know that what is the gravitational force. Whenever the body is releases from certain height without any force is applying, just release from certain height, then body comes to ground because of the auxiliary, because of the gravitational influence, means the gravitational force is acting on that body. So that's why here the gravitational force is acting on that body. This is also one of the type of the force, that is gravitational force. Coulombic force, whenever the two charges are separated at distances, the force between the two charges will be acts as, that is called as the Coulombic force, and as well as the electrostatic force and electromagnetic force, means whenever the magnets, whenever the current passing through some of the medium, then some of the magnetic field around the some of the field is occupied, so that force which acts on the others particles, the charges, is called as electromagnetic force. Nuclear force, this means to say whenever the neutrons, means protons, electrons are acting on the body, then if the proton, all the protons having the positive charge also stays in the nuclei. To state the total positive charge at a point in the center of an atom, that is called nuclei, the sum of the force is acting more than that repulsion between the protons. The force is called as a nuclear force is acting on that. So that's why the total proton positive charge stays at the middle of the, means center of the an atom, that is called as a nuclei. And cohesive force. Cohesive force means whenever the two same type of materials which is having the both same type of materials having the attraction between them, those are called as a cohesive force. And adhesive force. Adhesive force means the attraction between the two different, the force between the two different materials is called as adhesive force. Like nowadays we are getting that the adhesive plasters and adhesive to stitch the wall. Anything if we want to stitch to the wall, then adhesive plasters are available in the market, which can be used for to reduce the leakage of tanks. There are also some of the adhesive material which is used. So that is adhesive force. Adhesive force, which can be the attractional force between the any two different materials. Then frictional force, earlier we discussed, if we want to walk, if you want to ride a bicycle, if we are sitting on the bicycle without any riding, then after some time, after moving some distance, the bicycle will stop automatically because of the some of the force acting between the tires and the floor. So that's the road. So that's why here the force between the frictional force is acting between them. So that is called as frictional force and muscular force. These are the types of forces: gravitational force, Coulombic force, electrostatic force, electromagnetic force, nuclear force, cohesive force, adhesive force, frictional force and muscular force. These are the four types of forces, and moreover etc. also there. Then this is about force. Next we are going to know about the inertia. What is inertia? What is meant by the inertia is nothing but generally we can say that the laziness, means the body which cannot be changes, tries to changes, unable to change. It's a state of rest or of uniform motion. Whatever the state is there, the body will stays. That will continue its state, same state, which is the property which is having by the body, means the inherent property of a body, which is unable to change its state by itself, either it's a state of rest or of uniform motion along a straight line, which is unable to change its, which is not ready to change its state, which is unable to change its state, is called as inertia. Means here, if the net external force is 0, it must be, you get that, net external force is 0. Whenever the net, there is no any force is acting on that body, the net external force is 0. Externally we are not using any force. A body continues to be at rest, or a body in motion continues to move with a uniform velocity. Means if the body, we are not using any force on a body, then according to the first law, already we know that Newton's first law, a body continues its state, every body continues its state of rest or of uniform motion unless we applied any external force. So that here the body continues its state of rest when the external force is 0, net external force is 0, it continues its state of rest and a body is in motion, continues to move with uniform velocity. That property of a body is called inertia. That property of a body is called as inertia, or either we can write that it is an inherent property of a body, of a material body, by virtue of which it opposes to change, which opposes to change means we can say the resistance of a body to change its state of uniform motion. This also we can write that the resistance to change the state of uniform motion is also called as inertia. Means if the body changes, by virtue of which it opposes the change in its state of rest or whether body is in uniform motion, then which is opposes the changes in motion is called as inertia. So lightly we can write that it is the inherent property of a material body which opposes the change, by virtue of which it opposes the change in its state of rest or of uniform motion is called inertia. It depends on that mass of a body, so that's why the mass is the measure of inertia. Mass is the measure of inertia, and it can be denoted as we know that mass can be measured in kgs. So that's why the SI unit of inertia is also kgs. Means the measure which gives by the mass. The measure of inertia which gives by the mass. So that's why we can say that the unit is also kg. SI unit is a kg. So also inertia can be written as the resistance to change the state. The resistance to change the state means if the external force is acting on that 0, by itself that body cannot change itself, its position. So that's why that is called as here inertia. And inertia is also 3 types. The first one is inertia of rest, and the second one is inertia of motion, and the third one is inertia of direction. It is nothing but inertia of rest, inertia of motion, and inertia of direction. So total value, these are the 3 types of inertia is that. First of all, what is inertia of rest? What is inertia of rest? Means if any body is moving with some velocity in a direction, in some of the direction, or while we are standing in the bus stand, we are standing in the bus is at rest, we are standing on the bus. If the bus suddenly starts, then we will fall backwards, but our feet stays with the bus. Means the body, remaining body, whenever the foot is contacted with the bus, so that's why it is connected with the bus, so that's why that will move forward with the bus. Whenever the bus suddenly starts, the feet will go with the bus, moves with the bus. The remaining body will be in inertia of rest, so which is unable to change by itself suddenly. So that's why here the remaining body will be stays at rest. So that's why the body fall backwards. The body fall backwards. Or by taking a glass and some of the flip card is on the mouth, put the flip card on the mouth, then some of the coin placed on the flip card, cut, then whenever the flip card taken suddenly, then the coin will be falls on the glass. Because of the coin will is at rest, which is inertia of rest. Due to the inertia of rest, whenever the cord is flicking off, the coin will be fall in the glass. If the cord will not taken suddenly, by taking the smallly, that body is also comes, the coin is also comes with the cord. Whenever the force is applied on the cord, whenever we remove that cord, suddenly flicking of the cord, then the coin will stays at inertia of rest. So that's why the coin stays at the same position and it will fall in the glass. Same here, when the body, when we are standing on the bus, when the bus is at rest, if the bus suddenly starts, moves forward, our feet with the move with the bus, so that's why our feet will move with the bus to the forward direction, and remaining body will be inertia of rest, so that's why it will fall backwards. That is about inertia of rest. The definition of inertia of rest is the inherent property of a body by virtue of which it unable to change by itself the state of rest, its state of rest, which is unable to change its state by itself, the state of rest. Means whenever the card is flicking off, the coin which is unable to change its state of rest, so that's why that stays the same place and it fall in the glass. Same as here also, whenever we are standing on the bus, whenever the bus is moves forwardly, suddenly in forward, then our feet will move with the bus, and when our body will fall backwards. So that's why here the inherent property of a body by virtue of which it is unable to change by itself, its state of rest is known as inertia of rest. Means already we said there that when we are in the bus, that starts suddenly our feet go with the bus, the rest of the body remains say where it is due to the inertia of rest, due to the inertia of rest. The next one is inertia of motion. The second one is inertia of motion. Inertia of motion. Inertia of motion is nothing but whenever the bus is in motion, when the bus is in motion, stops suddenly, we fall forward direction. Why? Because when the bus is in motion, the body is also in motion with the same velocity with the bus. But when the bus suddenly stops, our feet with the contact with the bus, so that's why our feet will changes its state suddenly with the bus because of the contact with the bus. Our remaining body will be continues its motion due to the inertia of motion. Due to the inertia of motion. The inherent property of a body by virtue of which it's unable to change by itself its state of motion. Its state of definition of say will be same. If in case of the state of rest, we can write that state of motion. Means the inherent property of a body by virtue of which unable to change its state by itself from the state of its motion. If the jump, whenever the man wants to jump over some certain height, he will come by running with some of the distance, which helps to jump for the long distance. So here, due to the inertia of motion, when the bus suddenly stops, when the driver puts a brake, the bus suddenly stops, our feet will stop with the bus, but the remaining body will be continuous its state of motion, which is unable to change by itself to be in comes to rest. It will continue its motion, so that's why that is due to the inertia of motion. The next third one is inertia of direction. Inertia of direction. The inertia of direction means simply we can say that whenever the bus turns to the one side, means if the bus turns, driver turns his steering to the left side, our body falls to the right side. And if he turns the bus to the right side, our body falls to the left side. Because of we are staying like this, motion is going in the same direction. But whenever the suddenly bus turns, our body which is not ready to turn with the bus, so that's why it will stays at the inertia of direction. So that's why we will fall left side. If in case bus turns to the left side, we will fall right side. So the inherent property of a body by virtue of which is unable to change by itself the state's direction. It's a direction of motion is called inertia of direction. This is about inertia and about force. This is Newton's first law of motion. Next we are going to know about momentum. Momentum, that is denoted with P. Here we do know that if in case of a mass of a body considered as m, and whenever it is moving with velocity v, the product of mass and velocity, the product of mass and velocity of a body is called its momentum, or the ability of a body to impact or tends to impart the motion to other bodies, to impact or to tend to impact the other bodies in motion. That is called as a momentum. Means whenever the body is having some, for example, if you are riding, if you are a bike is riding, you are riding a bike, then it is having some mass and is moving with some velocity. So that means to say that body possesses some momentum, that body will be in momentum. In case of two type of momentums are there, whenever the body is moving along a straight line, that can be considered as a linear momentum. Either if it is making an angle, then that will be the angular momentum. Means if it is in a rotational motion, if it is in a rotational motion or in a circular motion, that can be considered as a angular momentum. So here this is about a linear momentum. When the body is moving along a straight line in the direction that is considered to be the product of that mass of a body m into the velocity of a body v can be considered as momentum is equal to momentum p is equal to mass m into velocity v, that is p is equal to mv. The formula of momentum means the body is in motion. If the m mass of a body is in motion with some velocity, then it can be said as that body is in movement, that body possesses momentum, which is impact or tends to impact the motion of the other bodies also. So that is about it's a vector quantity is having specific direction and as well as a momentum, so that magnitude, so that's why it's a vector quantity, and it can be measured in a kilogram meter per second. Here mb the kilogram, velocity means meter per second, so kilogram meter per second, that is the SI unit of that momentum. And dimensional formula will be here m power 1, L power 1, T power minus 1, means kg is the mass, so that's why m power 1, and meter means length, L power 1, this time seconds power it is minus 1, so that's why m power 1, L power 1, seconds time will be T power minus 1. This is about dimensional formula of momentum. Here if in case of the next net external force is on your body is 0, then the momentum will be is constant. The momentum will have constant. The body will have a constant momentum whenever the external force is net external force is 0. So that we can say that the momentum is changes by the influence of the net external force. If the net external force is applying on the body, then the momentum is also changes. So that in case of that we can say that when the net external force is 0, the body will have the constant momentum. So momentum can changes by the influence of the net external force. So this is about the general information about the momentum. This is the terms which can be discussed about in the Newton's first law of motion.